right, folks, let's take a look at our last one. So before I do anything, let's find these LCDs. I can see I got a GCF here. This is P plus 1. Over here, I've got a GCF of n squared, so this is n squared, n plus 5. Okay, so let's put together our LCDs. So here I need, these are both P plus 1. So I need a P and a P plus 1 in my LCD, and that covers this denominator here. So there's my LCD. All right, here for my LCD, I've got an n squared and an n plus 5, and that will cover these two. So my LCD is n squared, n plus 5. All right, and I'm gonna multiply like I've been doing every term in my rational equation by that LCD. And it will knock out the fractions, and that's something we're doing by design. And once I knock out the fractions, I'll either have a linear equation to solve or a quadratic, and we'll just see. So here we go. I'm gonna go ahead and start with P plus 1 times this first fraction of P plus 5 over, now instead of P squared plus P, I'm gonna write that denominator in that factored form so I can see more easily what I'm going to cancel. So LCD times that next fraction of 1 over P plus 1 minus, and we've got P plus 1 times P minus 6 over P plus 1. All right, so let's see what cancels. The P's go, the P plus 1's go. The P's go, the P plus 1's go. The P plus 1's go. All right, so let's see what's left. Over on the left side, I'm gonna have P plus 5. So far it's linear. On this side, I'm just gonna have a 1. And then I'm gonna subtract out P minus 6. Oh, so I can see I am gonna have a quadratic term eventually because I am gonna have to distribute the P to the P. All right, so let's be careful distributing this negative. P plus 5 is gonna be 1, okay. P times P is P squared, but negative P times positive P is negative P squared. Now negative P times negative 6 is positive 6P. So I am looking at a quadratic equation. And when I have a quadratic, I say quadratic because we got P squared. When I have a quadratic equation, what I want to do is get all the terms on one side, set my equation to 0. I also personally, hold on, I see a little minus sign here. I personally like to have a positive lead coefficient, so I'm going to move everything this way. So I'm going to add P squared to both sides, and I'm going to subtract 6P, and I'm also going to subtract 1. Okay. So if I add the P squared over, I'm going to have P squared here. P minus 6P is going to leave me with minus 5P, and 5 minus 1 is going to leave me with plus 4. That's going to be equal to 0. And at this point, you can factor or use the quadratic formula. I'm going to factor because I can see this is P minus 4 times P minus 1. And when I set each of those factors to 0, right, either P minus 4 is 0 or P minus 1 is 0, I get that P is either, and I'll push this over here so we can see it, P is either 1 or 4. And both of those are fine answers, because I just need to worry about if I was solving this and got 0 or negative 1, then I would throw those answers out. But this is fine. Okay, let's do the same thing and send our LCD of n squared n plus 5 through. So I'm going to do n squared n plus 5 to this first fraction. And instead of writing n cubed plus 5n squared, I'm going to write it out in factored form, n squared n plus 5. All right, that's going to be n squared n plus 5 times 4 over n plus 5 plus n squared n plus 5 times 1 over n squared. All right, and a bunch should cancel. That's the whole point. N squareds go, n plus 5s go. N plus 5 goes, n squared goes. And let's see what we have left. So the only thing on the left side itself is 5. This is going to be 4n squared. And this is going to be plus n plus 5. All right, so I've got a little bit of a quadratic equation here. Again, if I either want to factor or use the quadratic formula, so I want to set it to 0. Let me move the 5 over. And I'm just going to write this on the left side. So I have 4n squared plus n equaling 0. And again, if you prefer to factor, by all means, go ahead and factor. I'm personally going to use, I meant to say, if you prefer to use the quadratic formula, by all means, go ahead and use the quadratic formula. I personally prefer factoring, so that's what I'm going to do for this one. I'm going to take out the GCF of n. I'm going to get left with 4n plus 1. So when I solve those linear equations, either n is 0 or 4n plus 1 is 0. So there's one of my potential solutions. When I solve for n here, I'm going to subtract 1. 4n is going to equal negative 1. I'm going to divide both sides by 4 and get n equaling negative 1/4. And when I go and I double check my answers, I see that n equaling 0 is a problem. Because if n is 0, this denominator zeroes out and this denominator zeroes out. So this is not actually a solution. But if n is negative 1/4, everything's okay. I keep that as a solution and I'm good to go. Thanks so much. Bye.